Hello and welcome to the review of Unit 1, Section A, the challenges of natural hazards. And to go with this module as well, you have your normal kind of revision questions just to help you out and just to go through, check your understanding and that you get the unit. So it's split into a couple of sections, so we'll only be doing the first two sections here today. Just the natural hazard, so what is a natural hazard, how does it affect? And number two, what are the tectonic hazards with the case studies of Chile and Nepal. Okay, as you're working through this, I'll be going through these questions or answering these questions. That'll be your job to get them in and to write the right answers, as well as insert some images as well. So insert 3 images of plate boundaries you see here, as well as insert some pictures of earthquake-proof buildings, for example. So as you're looking through the video, please do that as well. Right, so the first bit of this natural hazards is what is a natural hazard and how do we kind of identify that? So what is a natural hazard? Well, it's a normal event not influenced by humans. Okay, well, obviously some can be influenced by humans now, and it has to impact property or life or human activity in some way. That way it creates a natural hazard. So you can see here from this diagram, if a natural event happens, so that's not a natural hazard, okay, an earthquake or flood, but it's nowhere near people or human activity, it's not a hazard. Okay, it's just an event or a natural event which has occurred. If the hazard or natural event here overlaps with people and human activity, that's when it becomes a hazard. It's about that overlap between human activity and the natural event. Again, it'll have huge impacts on social, political, and economic impacts as well. So that's your first question there. What is a natural hazard? A few examples down here for you, nice and easy. Volcanic eruptions, earthquakes, storms, tsunamis, landslides, and floods. Lots more in here. You can have wildfires, droughts, even snowstorms, avalanches, mud flows, and so on. Okay, lots and lots of different types of natural hazards. Then go on to kind of question 3 here. So it's only a very short section, this what is a natural hazard, and it gives us a few examples of what could make a hazard worse or what could make a hazard better. And for example, urbanization, so the building of cities, okay, the amount of people, percentage of people living in cities, the more people in cities means the more impact from danger or hazards. So a good example it talks about here is Tokyo, one of the biggest megacities in the world, population over 30 million. Is by an earthquake-prone boundary, and it could cause more deaths if it's more densely populated. So the more urbanized the place is, the more deaths that can occur, unless we're talking about development of a country. Haiti is a good example of this as well. Port-au-Prince, the capital, when the Haiti 2010 earthquake killed nearly 230,000 people. The second question I put in this, how does actually it can have a positive effect. So when we're talking about river flooding, for example, actually the rivers, when they flood, they deposit loads of fertile silt on the floodplains, which is excellent for farming and good for kind of poorer countries like Bangladesh or in the Ganges and India and so on. When there's river floods, it makes the lands really, really fertile. It's really good. So sometimes our hazards actually have positive impacts as well, not just negatives. We then go on to the second section here, which is all about tectonic hazards. What's our plate boundaries? What are they? What types are they as well? So we're going to look at the distribution of earthquakes and volcanoes. It's a nice map just showing you the earthquakes recorded in 2015. And here's tectonic plates as well. So there's some key facts about what tectonic plates are. They're generally split into 2 categories. Oceanic and continental. So there's 2 types of crust. It says it here, oceanic and continental. Oceanic tend to be less dense and they sink below the thick continental crust when they collide. Tend to be about 100 kilometers thick as well, and they move in relation to each other. They can move away from each other, towards each other, or side by side as well. And where on these plate boundaries or these plates, the edges, we tend to find our volcanoes and earthquakes as well. And here's a nice diagram. So as well as getting some of these key facts in, it'll be also good for you to get a key diagram of where our tectonic plates are. That's made of the crust, isn't it? So imagine if the Earth's top layer is like a plate and has been kind of smashed and put back together, that's what it kind of looks So where do volcanoes happen? Is another key question that kind of goes on to the second one here. Where do the majority, and we call this kind of ring of fire or this belt around the Pacific Ocean, or if we look at this boundary, the Pacific plate here. Okay, and what happens is because there's lots of destructive plate boundaries, so I'll draw quickly on here. This one moving in this direction, this one moving in this direction. Okay, it causes a chain of volcanoes all around the edge of the Pacific Ocean, bordering the majority of East Asia, the majority of west coast of the Americas, and South America as well as around New Zealand and the South Pacific Islands. Okay, so if you're describing where the majority of volcanoes happen, that is the place, as well as down the middle of the Atlantic Ocean here. But they are generally, and the exam board accepts this majority of the times, they are on the edge of plate boundaries. Why is there a pattern? Obviously, because they're on the edge of plate boundaries, but there's also a few anomalies here, and I highlight them in red. We've got one in the middle of the ocean here. We've got a few down here. We've got one over here. We've got one up here as well. They're what we call hot spots. So they're just locations within the mantle where it's really, 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 really hot, and it's caused volcanoes to come out away, or normally central of the plates, away from these kind of plate boundaries which we expect. So they're called hotspots. Then look at the physical processes which affect our plate boundaries. So our different types of plate boundaries here, we've got a few. We've got constructive, destructive, and conservative. Okay, there are three types of plate boundaries. Constructive, as it kind of says in the name, creates land, and these are two plate boundaries which move in opposite directions as seen from this diagram here. And what we get is it moves across. Volcanoes are created in the middle, like shield volcanoes, we call them, very runny, very low viscosity lava, and it creates a chain of volcanoes in the middle, and we call this the Mid-Atlantic Ridge or an ocean ridge, and normally under oceans. It's normally oceanic and oceanic. There's a bit more detail here if you want to put that in as well. Destructive is when two plates move into each other, and that's normally oceanic here and continental here. We said the oceanic is less dense and it's less thick, so it normally sinks below our continental plate here, and as it sinks below into this area we call the subduction zone, it starts to melt. This melting causes magma to rise, and we get very explosive, destructive volcanoes here as well. What we call these composite cone volcanoes, or it says here composite volcanoes, which are very explosive and very violent. The South America is a good example of this, off the coast of kind of Japan as well as the Pacific Islands. Pacific Islands is also part of this. Don't just have to be oceanic to continental, though. It can be continental, for example, India into Asia, which creates the Himalayas. We've then at the bottom here got conservative, and this is where it just moves side by side. So the most famous one of these is San Andreas Fault. They can be moving, as you see in the San Andreas, in the same direction, except one side is moving slower than the other. Okay, and what happens then, it still builds up friction, or you can get it the opposite way, builds up friction, no volcanoes here, and when the earth tends to slip or fault, okay, we get earthquakes across this line here. Okay, so a very simple one is conservative, but it's more about the features. So make sure if you're talking about the features, constructive, we've got a mid-ocean ridge. The destructive, we've got composite cone volcanoes and fold mountains, as well as what we call an ocean trench in here. And the conservative is just really earthquakes and a fault line we normally find as well. We then go to look at the effects of earthquakes, and we look at two examples here, and I'll leave you to do a lot of this reading and go through it yourself. But the main things is Chile versus Nepal. So Nepal, quite a poor country. Chile, domestically a bit better than Nepal, but not quite a lot better. But we can look at the primary effects of these earthquakes and how many are injured, because they're still devastating for both. So around 500 people killed in the Chile earthquake compared to 9,000 killed in Nepal. 800,000 people were affected here, and over 8 million were affected by Nepal. So we can already start to see the primary and long-term effects were a lot worse for Chile than Nepal. So you're more than welcome to pause the video at this point and kind of write down a few of these key effects for each. Then we look at the responses. So responses are split into immediate and long term. So obviously emergency services are key. Satellite phones and floating bridges for everyone that need repairs. 90% of water and power restored in 10 days. 200,000 households are planned to be reconstructed. That was in Chile. For this one, 300,000 people migrated from Kathmandu, the capital city, to seek shelter, helicopters, rescue operations, 500,000 tents. That's very immediate. And then we've got nearly over 7,000 schools to be rebuilt, repaired, and a lot of heritage sites and tourism to be brought back more long term for Nepal. Okay, so again, pause this on this page and get some key notes about the responses made in each that you can compare. We then look about living around with these tectonic hazards. So why do people do it? Okay, so you should be around about here now. So why do people live around volcanoes and what are the benefits for it? Obviously, scenery. It could be culture. It could be the fact they've lived there all their lives. It could be a very historical reason. It could be picturesque. It could be very beautiful as well. There's lots of reasons around here. Like they've had their properties and money secure there for years. That's what it is. Better building design can help you withstand in those areas. But there's lots of benefits to this. So on the second question here, lots of benefits. Hot water, geothermal energy, one big benefit. Volcanic rocks can cause a lot of minerals to form, so mineral resources, gold, diamonds, and so on. Hot water, free heating. We can also look at tourism as well, increasing around these areas, more fertile soil as well. Dramatic landscapes, Iceland's are really good. There's glaciers, volcanoes, waterfalls, all carved out and helped by volcanism. So that's the why people live is around about here, and the reasons for living and the benefits of living is here. So there are benefits about living in these tectonic zones. It's important that if we know the benefits and we know people are going to live around them, what we can do to protect, monitor, and predict. So volcanoes, second last bit here is how can we monitor and predict volcanoes? So monitoring volcanoes is here. Okay, we can look at the gas, we can look at the sides, and is the volcano swelling? We can look at heat escaping, we can look at sulfur, melting of snow, more visible signs of lava actually coming out of the volcano at a more regular intervals, as well as what we call like earthquake swarms within the volcano, seeing the rising. So that's how we can kind of predict or look at the volcano as well. And it goes through a bit more in here: remote sensing, seismicity, ground deformation, geophysical measurements, gas hydrology. Earthquakes generally occur without warning, though, so earthquakes are a lot harder to predict. We can't really do that very, very well. The only one you can put here is what we call the seismic gap theory. So this is the plate that runs through Turkey here. And what we notice is each year is when a major earthquake has kind of occurred. What we notice, and I'll draw the arrows, earthquakes tend to move this direction by a certain distance every certain amount of years, but we're overdue one in the capital of Istanbul as well. So we'll get that one hopefully, well, not hopefully soon, but it was moving along the plate boundaries. One way to predict, again, it could be years, it could be days, it could be minutes. It's a lot harder to predict than volcanoes. So we can't predict them. We need to protect against them, or if we can't predict them very well, we need to protect against them. Volcanoes, because we can predict against them very, very well, evacuation is the main form of protection. Very little can be done if they're incredibly explosive. Maybe we can channel the lava somewhere else to stop the lava flows, but the main big pyroclastic and ash clouds we can't stop very well, but we can evacuate, stop planes from flying, and so on. Earthquakes is mainly buildings and warning systems that the earthquakes or tsunamis are going to go off. Here's an example of a building here. So walls reinforced with steel, shock absorbers underneath, a lot more flexible foundations in the buildings, automatic shutters as windows will smash and break quite easily to stop glass falling everywhere. Open areas near big high-rise buildings. So if they do fall, people are able to evacuate and be safe in open areas. And weights that roll on the top of the building to the opposite side the building is falling in order to counteract shaking of the earthquake as well. The main thing that I would always mention in terms of protection is evacuation and warning systems for both of these, and mapping the hazards and where they're going to impact and take place. That's the whole of those first two sections there for natural hazards and tectonics. I'm more than welcome to watch the video back, stop, pause, record, go through and look at the book as well. What I'll slowly just do is flick through the pages slowly here, so you're more than welcome at the end of the video just to pause on any pages you need more information and zoom in and so on. I'll just slowly go through. We start off with natural hazards, distribution of earthquakes and volcanoes, physical processes of plate margins, the effects of earthquakes, responses to earthquakes, living with the risks from tectonic hazards, reducing the risks from tectonic hazards, and then we go into weather, which we're not doing yet. So use them for revision, use this video and fill in the sheet as best as you can and finish within the lesson.